At the heart of the solar system is our star, the Sun. This gigantic ball of hot glowing plasma provides the Earth with an abundance of energy that we call sunlight, and it is this energy source that allows life to flourish across the entire planet. Light that is emitted from the Sun or the distant stars moves incredibly fast. In the vacuum of space, a photon of light travels 186,282 miles every second. And in theory, nothing can travel faster than light, making it the cosmic speed limit. It is so quick that if you could achieve the impossible and travel at the speed of light, you would be able to circle the Earth at the equator nearly 7 times every second. But although the speed of light is incredibly fast compared to anything that we encounter on a daily basis, it is also frustratingly slow when it comes to travelling the vast distances that the universe demands. Like all of the planets in the solar system, Earth travels on an elliptical orbit, and so our distance from the Sun varies slightly over the course of a year. However, on average, we are 93 million miles away from the Sun, which means that light that has escaped its surface, travelling at the cosmic speed limit, takes approximately 8 minutes and 30 seconds to reach us. If the Sun was to suddenly disappear, for example, it would take just over 8 minutes before we even realised it was gone. Our neighbouring planet, Mars, is on average 142 million miles away from the Sun, which means it takes light roughly 12 minutes and 42 seconds to reach its barren surface. Because the red planet is farther away from the Sun than we are, it receives approximately 44% less sunlight, making a daytime on Mars about as bright as a cloudy afternoon here on Earth. Travelling through the asteroid belt, past the orbit of Jupiter and onto the ringed world Saturn, which is on average 891 million miles away from the Sun, would take a photon of sunlight 1 hour and 11 minutes to arrive at the giant gas planet. And going beyond the orbits of the ice giants Uranus and Neptune to the distant dwarf planet Pluto, which is on average 3.67 billion miles away from the Sun, would take light a lengthy 5 hours and 28 minutes. This means that if you were able to stand on Pluto's icy surface and look up at our solar system's star, you would always see it as it was over 5 hours ago. Because of the incredibly vast distances between objects within the Milky Way galaxy and beyond, travelling outside of our solar system requires a much larger unit of measurement, and so at this point, using miles, kilometers, or even astronomical units is not practical. A commonly used unit for this great distance is a light year, which is the distance light can travel in a single Earth year. An incredible 5.88 trillion miles. For example, the closest star to the Sun, Proxima Centauri, is 24.9 trillion miles away, which means that light travelling to this neighbouring star would take roughly 4.25 Earth years to get there. To put that into some sort of perspective, the famous spacecraft Voyager 1 is currently travelling away from the Sun at a rate of 10.7 miles every second. But if we could redirect the craft so it was heading towards Proxima Centauri, it would still take over 76,000 years before it arrived. The brightest star in the night sky is called Sirius, and is the primary star in the constellation Canis Major. Sirius is roughly 8.6 light years away, which means that every time you look up at this bright star and see it flickering in the darkness, that light first began its journey to your eye over 8 years ago. At the center of the Milky Way galaxy is a cluster of 200 to 400 billion stars that all surround a supermassive black hole called Sagittarius A star, which is about 4.31 million times the mass of the Sun. For sunlight to get to this mysterious region, it would take over 25,640 years to arrive. That means that the same sunlight that the ancient Neanderthals were basking in just before their extinction is only just arriving at the center of our galaxy. Travelling outside of our galaxy presents even larger distances. The closest spiral galaxy to the Milky Way is Andromeda, which lies more than 2.5 million light-years away. If you could stand on a planet within the Andromeda galaxy and somehow look back at our star, you would be seeing the light that left the Sun when our species was just beginning to establish itself. The greater the distance an object is in space, the longer it takes its light to get to us, and the older that light is when it finally arrives. Light can take millions, sometimes even billions of years to reach us, so the further out we look, the farther back in time we are able to see. And by using large, incredible telescopes such as the Hubble Space Telescope, we are able to peer billions of years into the past and observe the wonders of the universe.